All right, so let's take a look at the questions you had to try. Number 1 says a metronome, which is just something that lots of musicians use to keep the beat, beats 54 times over a 55 second time interval. 54 times is your N, and your delta T is 55 seconds. Okay? Determine the frequency in the period. So frequency is equal to N over delta T, or 54 over 55 seconds. So frequency, when you do the math, is 0.9818, and the 18 repeats, hertz. Period, on the other hand, is equal to delta T over N. So it's 55 seconds over 54. So period is equal to 1.0185 seconds, with the 185 seconds repeating. So period is measured in seconds, frequency in 1 over seconds, which we call a hertz. Number 2, most butterflies beat their wings between 450 and 650 times per minute. Calculate the in hertz the range of the typical wing beating. Okay, so 1 N is 450 times, and the delta T, it said, was per minute, so 60 seconds. So we can find the frequency of this one, N over delta T, 450 over 60 seconds, 45, so 8.5. F is equal to 8.5 hertz. Maybe 7.5 would be better. Too bad I don't know my times table. 7.5 hertz, like I was saying. The second one, the second N, is 650 times, still in 60 seconds. So F equals N over delta T, 650 over 60 seconds. F equals 65 over 6, 10.83 repeating hertz. So what's the range? Between 7.5 hertz and 10.83 repeating hertz. Number 3 says a watch spring oscillates with a frequency of 3.58 hertz. How long does it take to make 100 vibrations? So this time they're telling us the F is 3.58 hertz, and they're telling us the number of vibrations is 100, and they want the delta T. So we know F equals N over delta T. So delta T equals N over F. N is 100. F is 3.58 hertz, which is a 1 over seconds. And I'm going to write that so that you can see that, like, it'll be 1 over seconds, which will just be seconds. So 100 divided by 3.58 gives you 27.93, and the 3 may be repeating seconds. I didn't box these, did I? Okay, number 4 says a child swings back and forth on a spring 12 times in 30 seconds. 12 times, N, 30 seconds, delta T. Determine the frequency in the period. So F equals N over delta T equals 12 over 30. So F equals 4.4. 0.4 hertz. Maybe. Yeah. And T equals delta T over N. So 30 seconds over 12. T equals 2.5 seconds. Number 4 is done. So these should have been easy, hopefully. All right, next set, flip the page. Number 5 on 349 says, a longitudinal wave in a 6-meter long spring That's my delta D. That's how far the wave's going to travel. 6-meter long spring has a frequency F of 10 hertz and a wavelength, lambda, of 0.75 meters. Calculate the speed of the wave and the time it would take. So we can get the speed by doing V equals F lambda. So V equals 10 hertz times 0.75 meters. The speed of my wave is 7.75 up there, 7.5 meters per second. Then it wants the time it would take to travel, so we know VAV, which is our V, is equal to delta D over delta T. So delta T is going to be equal to delta D over V. Delta D is 6 meters, the time is 7.5 meters per second. 15 goes into both. 4 over 5.8, I believe. Delta T should equal 0.8 of a second. All right, number 6 says interstellar hydrogen gas emits radio waves with a wavelength of 21 centimeters. Given that the radio waves travel at 3 times 10 to the 8th meters per second, what is the frequency? So the wavelength is 21 centimeters, or 0.21 meters, and the speed is 3 times 10 to the 8th meters per second, and it wants frequency. So we know V equals F lambda, so F is going to equal V divided by lambda. So 3 times 10 to the 8th meters per second divided by 0.21 meters should give us an F of 1.42858 times 10 to the 9th hertz. All right, turn the page again. Number 7. Tsunamis are fast-moving ocean waves typically caused by underwater earthquakes. One particular tsunami traveled a distance of 3,250 kilometers. Distance, that is not a wavelength, that is a distance. How do I know? Because it said it traveled a distance of 3,250 kilometers, so we're probably going to have to change that to meters, in 4.6 hours. Maybe not, though. 4.6 hours. That's time. Its wavelength was determined to be 640 kilometers. 640 kilometers. What was the frequency of the tsunami? So we can find our speed, because we know V equals delta D over delta T. So 3,250 kilometers divided by 4.6 hours should give you, in kilometers per hour, 706.522 kilometers per hour. And I'd probably change it now. And when you change it to meters per second, it's 196.256. I would have changed it here instead of each of these, because then I only have to change one. So once I have my speed and I have my lambda, now I can find F, because we know V equals F lambda, so F equals V over lambda. So 196.256 meters per second, and I have to change my 640 kilometers to 640,000 meters. And when I do, I get a frequency of 3.0665 times 10 to the negative 4 hertz. Okay. Next, I'm going to run out of time. Number 8 says, an earthquake wave has a wavelength of 523 meters and travels with a speed, V, of 4.6 kilometers per second, which would be 4,600 meters per second.